This is section 3.04 of the Unit 3 notes, housing. Today I am, as in you are the student, discussing costs involved in renting or buying a home so that I can calculate the amount of rent or mortgage payments and predict the future value of a home. I will know I have it when I can solve problems involving renting and buying a home. Specific techniques we're looking at for today's lesson is 3A. Use formulas to generate tables to display a series of payments for loan amortizations resulting from financed purchases. And 3C. Use technology to create amortization models to investigate home financing and compare buying a home to renting a home. This is just a quick little overview on the different types of housing that we have. We have regular houses, we have apartment buildings, we have tiny houses, we have duplexes where you have a single home with two sections, one for each individual family. And again, different view of apartments. This one looks like it's a 2-story apartment. We have another one that's a 3-story apartment. There are many different types of housing or apartments that you could buy and or rent. And we're going to be looking at different calculations that involve housing and or renting. So let's go to this next slide here. These are rules of thumbs that are just something safe for you to follow to kind of judge whether you should move forward with your purchase or rental, or if you should back away from it. Even though these are rules of thumbs, they are not law, they're not things that should dictate what you do, but they are just some things to kind of keep in mind to safely rent or buy a home. So for renting, you typically want to look at a 28% of your gross annual income to safely rent an apartment or rent something. And to buy something for sale, 2 times your gross annual income. Again, these are magic numbers that can allow you to do these things comfortably. Again, rule of thumbs, but that doesn't mean you should follow them all the time. They're just there to help you determine whether to move forward or not. We're going to look specifically at renting in this next example here. So, renting what you can afford. Step 1, we're going to multiply our annual salary by 28%. And step 2, divide by 12 to figure out the monthly amount needed to rent. So, again, this scenario, we're using the rule of thumb of renting. And we're trying to figure out, based on our salary, what would be an appropriate monthly amount to rent. So, for example 1, Mary's gross annual salary is $37,782. What is the maximum amount of rent she can afford to pay? And we're going to round to the nearest dollar. Let me cover some of this up and then reveal it as we go. So with step 1, for this rule of thumb, we're going to multiply the annual salary by 28%. However, 28% needs to be turned into a decimal. So either move the decimal point to the left twice or divide by 100 and we will get 0.28. And then you can see on my calculator, 28 divided by 100 is 0.28. Then we're going to multiply that with the gross annual salary. So $37,782 times 0.28 is $10,578.96. So this is how much you're expected to pay in rent for the entire year. However, we want to know what a maximum monthly payment should be in order for this to be affordable. So just to reveal what we just did, $10,578.96. So step 2, we're going to divide by 12 to find the monthly amount. So divide this by 12, $881.58. And it says round to the nearest dollar, which means we're going to round this to $882. The maximum amount of rent she can afford a month is $882. Again, this is a rule of thumb. This is not the absolute maximum, but this is something to think about in order to live comfortably with your rental. Because besides the rent, you also have to be responsible for bills, groceries, and other expenses like entertainment. Maybe you want to eat out every now and then. Maybe you need to save for other purchases down the line. This is a rule of thumb to be able to afford, comfortably afford renting a place. So, this is it for example 1. Okay, now moving on, you try number 1. At this moment, I would like for y'all to pause the video, try this problem on your own. Let me read it to y'all first. Al's gross annual salary is $68,935. What is the maximum amount of rent he can afford to pay? And the reason why we divided it by 12 in the previous one is because rent is paid off monthly. So that's why we divided it by 12. You're going to be doing the same thing right here in step 2. So anyways, go ahead, read through the problem, read through the steps, fill everything out if you're working through this in ClassCake as you're watching through this video. Try this on your own. Otherwise, I'm going to continue on and show y'all how to do this. So, step 1, multiply the annual salary by 28%. We know the annual salary is $68,935. So, $68,935. And then we're going to multiply this by 28% in decimal form, which is 0.28, like we did a little while ago, right over here. Either moving the decimal point to the left twice or dividing it by 100. Either way, we get 0.28. And then plugging that into the calculator. 68,935 times 0.28 is 19,301.80. 19,301.80. Because we're talking about money, so we need to round to 2 decimal places. If you don't see that second decimal place, then there's a 0 that you need to fill in. We're going to take this number divided by 12. So 19,301.8, 19,301.8 divided by 12. Rounded to the nearest dollar should be 1,608, so 1608. And this is the maximum amount of rent I can afford, or Al can afford to pay. Again, this is not the end-all be-all. This is just a rule of thumb to better help with the financial situation. But that's it for you try number 1. Okay, so another situation you may need to calculate is paying to move in. We're going to, step 1, find the amount of the security deposit. Whenever you're renting an apartment, they more often than not ask for a security deposit. That security deposit can be used for different things that involve maintenance, either before or after you move, or usually after you move out of your apartment. If nothing needs to be done, they give you that security deposit back. However, if there are some things that they need to touch up or clean up because of damages done to the apartment, they will use a part of that security deposit, and if they have any left, give it back to you, or you just may not use it in general. So the first thing we're going to do is find the security deposit, which is the monthly rent times a percentage. Then for step 2, to get the total amount to move in, you're going to add the first month, the last month, and the security deposit together. So let's look at an example. Example 2, for instance. Max is signing a lease for an apartment that rents at $895 a month. How much will he pay to move if he must pay the first and last month's rent and a security deposit equal to 70% of his monthly rent? So the first step, find the amount of the security deposit. Security deposit, according to the question, is 70% of his monthly rent. So we're going to use $895 and 70% in our calculation. However, 70% needs to be changed to its decimal form, which will be 0.7. Again, you can move the decimal point to the left twice, or you can also divide it by 100. Either way, you will get 0.7 as its decimal form. So now we're going to multiply 0.7 with the rent, 895 times 0.7. Rounded to 2 decimal places, this is 626.50. 626.50. So again, this is the security deposit that we just found. To calculate how much it'll take to move in, we need to add the first month, the last month, and the security deposit all together. So the first month and last month's rent is $895. So we're going to add that twice. 895 plus 895. And then we're also going to add the security deposit, which we found out to be 626.50. Altogether, in order to move in, you have $2,416.50. Right here. $2,416.60 to move into the apartment. And that's it for example 2. Okay, you try number 2. Janice is signing a lease for an apartment that rents for $1,100 a month. How much will she pay to move in if she must pay the first and last month's rent and a security deposit equal to 80% of her monthly rent? So go through each step. So there are 2 steps to take, and then you can move this box right here to see if you're going through the work correctly. So at this moment, go ahead and pause the video. Try this on your own in ClassKick or on a piece of paper and with a calculator. Otherwise, I'm going to show y'all how to do this. Okay, so the apartment is renting for $1,100 a month, and the security deposit is equal to 80% of her monthly rent. So I'm going to have $1,100 times 0.8, which again, we can move the decimal point to the left twice, or divide this by 100, and we'll get 0.8%. Oh, I'm sorry, just 0.8, not 8%. There we go. So we're going to get 0.8, multiply that by 1,100, and we have $880. This is the security deposit. So now, step 2, to figure out how much it's going to take to move in, we need first month's rent, $1,100, last month's rent, which is the exact same rate, and the security deposit, which was $880. Add everything up, and we get $3,080. This is how much you're going to have to pay to move in to your new apartment in this scenario. Or not you, Janice. Janice needs to move in. Anyways, that's it for you try number 2. So now I have a video titled Demystifying Mortgages. We're going to watch this video, and after we watch it, if you're on ClassKick, I would like for y'all to fill out this box below. Share one thing that you learned from watching that. Or if you have any questions that you may want to ask, go ahead and fill that out too. If you learned something new, if you already knew these things, whatever, I just want to see what your thoughts are from watching this video. So let's go ahead and watch this.
Hey, what's the big idea?
Oh, I'm sorry. I didn't realize you lived in there.
I don't. Well, not yet. I'm just here for the open house.
Are you gonna get it?
Well, I'm not sure. It kind of depends on the mortgage rates.
Ha! Good one. You're not joking. Sorry, I didn't realize hermit crabs need mortgages.
Of course we do. It's the biggest purchase of our lives. We usually need a loan to make it happen.
If I were you, I would just find the mortgage with the lowest interest rate and go with that.
It's not that simple. When shopping for a mortgage or any loan, financial institutions have products with an advertised APR, which stands for annual percentage rate.
That's what I mean. Just go with the one that has the lowest APR.
But you can't compare them at face value. The APR represents a combination of things. The interest rate, yeah, but also a wide range of additional costs. And if you're looking at an adjustable rate mortgage, the APR doesn't even tell you what your maximum interest rate will be.
You've lost me.
Look, mortgages come in two basic types: fixed rate and adjustable rate, also known as variable rate. In a fixed rate mortgage, the interest rate is set when you take out the loan, and it does not change over time. The amount you pay monthly will stay the same for the entire term of your loan. In an adjustable rate mortgage, the interest rate, and therefore your monthly payment, is based on current interest rates in the economy. If the index they're based on goes up, so does your rate, meaning you'll be paying more. If the index decreases, so do your payments. An adjustable rate mortgage often has a lower initial interest rate, which is very appealing.
Fixed rate, adjustable rate, how do you choose the best one?
It's always a trade-off. Fixed rate mortgages are more stable and easy to budget for, but have a higher interest rate overall. Adjustable mortgages have better rates, but are riskier because your rate may increase over time. You have to think about your income, your future, how long you plan to live in the home, your financial risk tolerance, and that's on top of weighing different mortgage types, interest rates, and amortization schedules.
Gesundheit.
Huh? No. Amortization. It's how your loan repayment is broken down into regular installments over a fixed period of time. An amortization schedule shows you how much of each payment is going toward interest and how much of it is going toward the principal.
Is it that hard to figure out? If your interest rate is 3%, then 3% of your payment goes towards interest. Am I right? Your face is telling me I'm not right.
That 3% is the annual interest rate. If you take the total amount owing on your mortgage and multiply it by 3%, the result is what you'll pay in interest in the current year. But the monthly payments work a little differently.
What?
Let's say you take out a 25-year mortgage for $150,000. It's a fixed rate, so you're paying $711 a month. In your first payment, $375 will go towards interest, and only $336 will go toward your outstanding balance. So even though you've made a payment of $711, your balance has only decreased by $336. The following month, because your outstanding balance is now $149,664, the interest portion of your monthly payment will also be slightly lower, and the principal portion will be slightly higher.
So looking at the entire stretch, even though a big chunk of my monthly payments are going towards interest at the start, over time, that kind of flip-flops. And by the end, more of my payment is going towards principal than towards interest.
Now you're getting it. Using this example, after 25 years, you will have made over $213,000 in payments on your $150,000 loan.
Whoa, that's serious.
All the more reason to know exactly what you're getting into before signing everything. People get into trouble by committing to mortgages they don't understand. It happened to a friend of mine. The bank came and took his shell away. He had to move into a half-eaten ice cream cone until he could figure things out.
That's rough.
Mortgages can be an empowering experience or a living shell. It all comes down to your understanding of the mortgage products available, honesty regarding your personal finances, and clarity about your life situation. As for me, this is a little too much home for my budget. Time to go house hunting. Keep it real.
So if y'all get the chance, fill out this box right here and just share what you've learned from that video, if anything. If you learned something new, if you already knew these things but then didn't know about one of the things that it showed you, or if you were just lost in the video and just kind of have questions about it, jot whatever you are thinking right there. Okay, so now we're going to go through some mortgage problems, some mortgage calculations. That video that we just watched was talking about mortgages and the different situations for buying or for going through mortgages. Going through a fixed rate, going through a dynamic rate where it just fluctuates all the time. There are different situations that you're going to get into depending on what type of house you buy. So we're going to go through calculating some of these house payments, starting with the monthly payment for the mortgages. So this may not make sense right now, but I'm going to go through the steps and then we'll go through the example right after. Step 1, calculate the down payment, which is the cost of the home times the percentage down. If you don't know what a down payment is, a down payment is essentially a payment that you make up front that actually takes off from the total price of the house. And then you will finance the rest of it through a bank or some other way. Step 2, we're going to calculate the borrowed amount, which is the cost of the home minus the down payment. Step 3, calculate the number of thousands borrowed, which is the amount borrowed divided by 1,000. If you remember in one of our previous sections, we used an amortization table to figure out how many hundreds we're borrowing and what rates to use from that table to calculate our loan payments. We're going to be doing the same thing but with mortgages. Step 4, calculate the monthly mortgage payment by taking the number of thousands borrowed and multiplying it by the amount you pay per 1,000. Okay, so again, let's look at an example and see how these formulas get applied. Liz is buying a home for $325,800. She is making a 20% down payment and financing the rest in a 30-year loan at 5.25% interest. What will her monthly mortgage payment be? So the table that we're going to use is in terms of a monthly mortgage payment. If you want to know where this table came from, it came from an amortization formula with a whole bunch of calculations already done to create this table. Okay, so we're using a shortened version or a shortcut to the formula, which is just we're trying to go around the formula by using some shortcuts. Okay, so we have this table already created and we're going to use that to find the monthly mortgage payment. Anyways, step 1, we're going to calculate the down payment. The down payment is 20% of the home. So 20% as a decimal is actually 0.2. And you can move the decimal point to the left twice or divide by 100. And we will get 0.2, which we're going to multiply to the cost of the house. So 0.2 times 325,800, which will be about $65,160. So that is the down payment being made, the money up front that will to pay for the house, which will also be taking away from the total price. So step 2, we're going to calculate the amount that's borrowed. We're going to take the cost of the home and subtract the down payment. Cost of the home was $325,800. We're going to subtract our down payment, which was $65,160. And we have $260,640 that we are borrowing from a bank or whoever it is that's financing it for this purchase. Okay. And again, doing a down payment helps a lot with what your monthly mortgage payment will be, because otherwise it would be much higher than what you're seeing right over here. Continuing on. Now, step 3, we're going to calculate the number of thousands borrowed. So we're going to take this number from step 2 and divide it by 1,000. Okay, so there's a couple ways you can do this. Move the decimal place to the left 3 times, and you should get 260.64, or simply divide by 1,000. And again, we get 260.64. And then step 4, calculate the monthly mortgage payment. We're going to use the table off to the right, and we're going to use the fact that this is a 30-year loan at 5.25% interest, which means 5.522 is the payment we're going to make per 1,000 borrowed. So we're going to multiply that with 260.64. 260.64 times 5.522. And we get $1,439.25 as our monthly mortgage payment. And that is your final answer. Okay, you try number 3. Steps are laid out. Here's the problem. Tom is buying a home for $426,000. He is making a 22% down payment and financing the rest with a 20-year loan at 5.25% interest. What will his monthly mortgage payment be? Step 1, calculate the down payment. Step 2, calculate the borrowed amount. Step 3, calculate the number of thousands borrowed. And then finally, step 4, calculate the monthly mortgage payment. So if you were on ClassKick doing this problem, I would like for y'all to pause the video and fill out the blanks on your own. See if you can get the right answer. If you get stuck, besides watching this video, if you want to figure it out on your own, just move this box to see where it is that you may have gotten it wrong. So again, pause the video, try this problem on your own. Otherwise, I'm going to continue on and show y'all how to do this. So, first thing we need to do is calculate the down payment. The down payment is 22% of the cost of the home. However, we need to change 22% to its decimal form, which will then turn into 0.22. Either move the decimal point to the left twice, or we divide this percentage by 100. Okay, and then the cost of the home was $426,000. Multiplying these two, we get 93,720. So 93,720. Step 2, we're going to calculate the amount borrowed. So now we're going to subtract the down payment from the cost of the house. So 426,000 minus 93,720. And we get 332,280. So 332,280. 332,280. Step 3, calculate the number of thousands borrowed. So we're going to use that number from step 2, 332.280. I'm sorry, comma 280. Divide that by 1,000. We get 3,300 and, oh, I'm sorry. Let's go back. Divide that by 1,000. 332.28. So now we're going to use 332.28 and the table to figure out what we are paying for our monthly mortgage payment. So we've got to go back. We know and look at some more information here. We know this is a 20-year loan at 5.25% interest. So from the table, we look for the 20-year part on the rows at the top, and then the 5.25 in the column. Zoom in, and we get 6.738. So that's going to get multiplied with the amount that we're borrowing, 332.28. 332.28 times 6.738. Rounded to about 2 decimal places, and we get 2238.90. 2238.90. And that is the final answer to you try number 3. This is the monthly mortgage payment that we just found. Moving on to a different type of problem, we're now going to look at calculating the total payment of a mortgage. So before, we were calculating the monthly mortgage payment, which also included the interest that is involved with these types of loans. With these types of problems, the first 4 steps are going to be the exact same. However, we're going to add steps 5 and 6. Okay, so after we calculate the down payment, calculate the borrowed amount, calculate the number of thousands borrowed, and then calculate the monthly mortgage payment, which again is where we left off on the previous problem, we are then going to calculate the total mortgage payments. So that's the monthly payment times 12 for the amount of months in a year, and then the number of years that the mortgage is being carried out. Then to calculate the entire payment that you or the person has to make, we're going to take the total mortgage payment and then add the down payment so that you can see what your total expense will be for the mortgage. So let's look at the next example, example number 4. So Liz is buying a home for $325,800. She is making a 20% down payment and financing the rest with a 30-year loan at 5.25% interest. What will her total payment be for the home? So this is similar to this problem right over here. I'm going to just briefly go over the steps in example 4, but we pretty much did the first 4 steps in example 3. So step 1, calculate the down payment. We take the 20% of the cost of the home. So $325,800 times 0.2 is $65,160. Calculate the borrowed amount. We're going to subtract these two numbers right here. Subtract them from each other. And we get $260,640 that's going to be financed for the purchase. Excuse me. Step 3, we're going to calculate the number of thousands borrowed. So we're going to take this amount right here divided by 1,000. We get 260.64. Step 4, calculate the mortgage payment. So this is based off of a 30-year loan at 5.25% interest, which means we're going to be using 5.522 and then multiply that with 260.64. We get $1,439.25. So everything up until this point we've done before in example 3. However, now we want to know what her total payment will be. So step 5. To calculate the total mortgage payment, we're going to take the monthly payment, which was $1,439.25, multiplied by 12. And then from here, multiply by the amount of years we're carrying out this loan, which is a 30-year loan. So multiply this by 30. And we get $518,130. Then the final part, to get the total payments for buying this house, we're going to add in the down payment. So now, take this mortgage payment, $518,130, and then add in the down payment, which was $65,160. And we get a total of $583,290. This is what you will have, or this is what Liz will have to pay for the total home. So notice how big of a difference this is with these mortgage payments, with how much money in interest the bank is going, or the whoever's financing the loan, the mortgage, notice how much more you're having to pay to get this finance. $325,800 was the original price of the home. When you finance this through a bank, through a mortgage, with the down payment, with the amount of interest earned over 30 years, you end up having to pay a total of $583,290. So nearly $250,000 more than what the original price of the home was. So there are pros and cons to this. The pros is you get to pay this at a reasonable monthly rate to afford the home, because not everybody can afford $325,000 on the spot. The cons, however, is you're having to pay way more than what the original price of the home was. So that's it for example number 4. You try number 4. So again, this is like you try number 3. We are this is the Tom's this is the problem that we've done with you try number 3 with Tom. Except now, instead of finding the monthly mortgage payment, we want to find the total payment. So the first 4 steps, steps 1, 2, 3, and 4, are all going to be the same. Except now, we're going to add in steps 5 and 6. Step 5, calculate the total mortgage payment. And then step 6, calculate the total payments. So at this moment, I would like for y'all to pause the video, go through this problem on your own. If you're doing this on ClassKick, fill everything out, and then go to the next page and check your work to see if you did everything correctly. Otherwise, I'm going to continue on and show y'all how to do this. So like I said, we've already done a lot of this in you try number 3, so I'm going to just briefly go over steps 1 through 4. Calculate the down payment of the home, that's $426,000 times 0.22. $93,720. That is the down payment. So now we're going to subtract these two numbers, 426,000 minus 93,720. And we get 332,280. 332,280. 332,280. Divide that number by 1,000. And we get 332.28 for the number of thousands borrowed. And then for step 4, calculate the monthly mortgage by multiplying that based from the table based off of a 20-year loan at 5.25% interest. So now let's look at the table. This is a 20-year loan at 5.25% interest, which means we're going to be using 6.738. So 332.28 times 6.738. $6.738. We get 2238 point something 0.90. Okay, so this is the monthly mortgage payment. I'm going to check my answer and make sure I did these correctly. 2238.90. Okay. Okay, so now for the added step 5 and step 6, we're going to take this monthly mortgage payment and find the total mortgage payments, which is $2,238.90 times 12 times the number of years that we're carrying this out, so, and which is 20. So multiply all that together, 2238.90 times 12 times 20, which is 537,336. 537,336. 537,336. This is the total mortgage payment. Now, to calculate the total payment overall, including the down payment, we're going to add that number, 537,336, plus the down payment, which was 93,720. So add 93,720. Oh, whoops. We get 631,056. 631,056. So the total payment with the down payment included is $631,056, coming from an original cost of $426,000. If we carry this loan out for 20 years with a 22% down payment at 5.25% interest, $426,000 turns into $631,056, which is a little bit over $200,000 more than what you originally paid for. Again, there are pros and cons to using mortgages to buy a house. This is one of those cons, but it makes it manageable, but for a lot more money. That's it for you try number 4. Yeah, I believe we got the right answer. 631,056. Yep, we did. 631,056. Okay, making predictions. Equations can be used to make predictions by evaluating the equation. So there's going to be a lot of plugging in and solving. First off, let's look at what the formula we're going to use is. This is called the future value formula. So P is equal to V parentheses 1 plus R close parentheses raised to the Y power. P is the predicted future value of a home. V is the original value of the home. R is the rate of appreciation as a decimal. And Y is the number of years in the future. Okay, so future value, this formula allows us to guesstimate or kind of predict what the value of the house will be in the future. Now, owning a house, usually over time, when you own a house over time, the value of that property, of that house, goes up in value. And so this formula is to predict what that value will be after a certain amount of years with a certain rate and a certain value. So houses appreciate, meaning go up in value over time. Here's an example. Let me just cover all of this up. So Stuart bought his house for $265,200. At a local real estate, a local real estate agent predicts that the house will appreciate in value 35% each year. That's a lot, by the way. Predict the value of Stuart's house in 20 years to the nearest dollar. So first off, when it says we're going to predict the value, or if we want to know what the value will be later on in the future, we're going to use this future value formula that you see right here. P equals V parentheses 1 plus R close parentheses raised to the Y power. So what do we have? We have the original value, which is $265,200. So this is the V right here. What else do we have? We have that it appreciates in a value 35% each year. So this is the R value. This is the rate of appreciation, which needs to be turned into a decimal. 35% as a decimal should be 0.35, either divided by 100 or moving the decimal place to the left twice. Amount of years that we're predicting into the future is 20, which is labeled as Y. We're trying to figure out the future value. So p-value, we don't know. We're going to use all these values and plug it into the formula, and you should see the following. V turns into 265,200. R turns into 0.35, and then Y turns into 20. Notice how P is by itself, and everything on the right side is a number that we can calculate. So we're just going to plug this into the calculator. 265,200, parentheses 1 plus 0.35. Close parentheses, and then get the exponent if you're using the TI-84 by using this caret symbol, so raising it to the 20th power. And we get, I believe, $107,213,355.80. If we round it to the nearest dollar, however, we get $107,213, or I'm sorry, $107,213,356 if we were to round this to the nearest dollar. And that's it for example number 5. You try number 5. So David buys a home for $278,640. His home is predicted to increase in value 4% each year. What is the predicted value of David's home in 18 years? So find out what each of these values are represented by, or what these letters, if there's anything represented by the letters, fill them out in this box right here. And then whatever you have from this box is going to be filled into the formula over here on the right. And then from the formula, get your final answer by plugging it into the calculator. Then move this box to check your work and see if you did everything correctly. Okay, so at this moment, go ahead and pause the video. Try this problem on your own. Otherwise, I'm going to continue on and show you all how to do this. All right, so first off, we need to identify what values we have. We know P is predicted future value, V is the original value, R is the rate, Y is the number of years. David buys a home for $278,640. That is the original value. So V equals 278. Let me do this in the color that it's in. 278,640. It'll increase in value at 4% each year. This is the R value. However, as a decimal, it should be 0.04. So 0.04 is the decimal version of that. The other thing that I have is 18 years. 18 years. So Y represents years. That's going to get filled in with 18. The value that we don't know is the P value. So that is not available, or NA for short. Now that we have all our information, we're going to plug it into the formula. This is a future value formula because it's asking for the prediction later on. And we have the following setup. 278,640. We have R as 0.04. We have the Y value as 18. And then we have the we don't have the predicted value, the P value, so that stays the same. All right, so now P equals whatever this is, all plugged into the calculator. So now we're going to plug it in as follows. 278,640, parentheses, 1 plus 0.04, close parentheses, raised to the 18th power. And rounding it to the nearest whole number, nearest dollar, we get 564,474. 564,474. Let's check our answer, and there we go. $564,474 is the predicted future value of this home after 20 years. Or, I'm sorry, 18 years. And that's it for U-Try number 5. And that's it for 3.04 notes in general. If y'all have any questions, let me know. Y'all have my information in the course. So just look for that there. Send me an email or a text message for any help on any part of the notes, or for parts of the quizzes and tests that doesn't make sense. I could hopefully steer y'all in the right direction if you would like me to. So that's it for this video. I will see y'all in the next one. Take it easy, everybody.